All right, 5.3, we're going to be solving trig equations. So before we were simplifying expressions, so we didn't have an equal sign in 5.1, we were just simplifying our trig. In 5.2, we were verifying, so we had to make one side equal the other side. Here we're going to be solving. So we're solving this as if it were a normal equation, except it's a trig function. So we want to get the trig function all by itself first. So what would I need to do to move everything else to the other side? Add 1. So 2 sine of x equals 1. What would we do next? Divide by 2. So sine of x equals 1/2. Now once our trig function's all by itself, we're going to look at the unit circle. Sine tells us to look at what on the unit circle? X, y, the y. So we want to see where on the unit circle is our y value 1/2. So we're going to go to our unit circle. Where do we have a y value of 1/2? Five pi over 6 and pi over 6. These are the only two where we have a positive 1/2 in our y spot. Good. So I'm going to say x equals, we said pi over 6 and 5 pi over 6. So these are our answers. All right, let's look at example 2. So we're going to do the same thing here, but we have a sign on each side. So we just want to combine them together. We're going to combine like terms and isolate our trig function. So what would I need to do first here? We want to combine our like terms, so let's add sine to the other side. What's sine of x plus sine of x? 2 sine of x, perfect. Plus square root 2 equals 0. Now we want to get our trig function all by itself, so what should we do next? Subtract square root 2. So 2 sine of x equals negative square root 2. What should we do next? Divide by 2. So sine of x equals negative square root 2 over 2. Now sine tells us we look at what on the unit circle? The y. I want to see where on the unit circle is my y value negative square root 2 over 2. So we're going to go to our unit circle. Where is our y value negative square root 2 over 2? 5 pi over 4. Anywhere else? 7 pi over 4. Perfect. So our answer is going to be x equals 5 pi over 4 and 7 pi over 4. What should we do first for example 3? Add 1. So 3 tangent squared x equals 1. Then what? Divide by 3. So tangent squared x equals 1/3. Then what? Square root both sides. Perfect. We're going to square root both sides, so it'll cancel out with the squared. So tangent of x equals what? What do we have to remember to do when we take the square root of both sides? Plus or minus square root 1/3. Now tangent, we have to look at what on our unit circle? Y over x. So it's not as easy as just looking at our unit circle. We got to do some math when we look at the unit circle. I want to see where y over x is the square root of 1/3. So let's go to our unit circle. If we figure it out in the first quadrant, that'll help us with the rest of them. So I want to do the math for the first quadrant and see what y over x is going to be. So y over x here would be 1/2 over square root 3 over 2. When we keep change flip, and we have a fraction and a fraction, this would be 1 over square root 3. Now let's pause for a second here. Is this the same as square root 1/3? If I were to simplify the square root of 1/3, I could say the square root of 1 over the square root of 3, plus or minus. Bless you. What's the square root of 1? 1. And what's the square root of 3? Just square root 3. So are these the same? 1 over square root 3 and 1 over square root 3? Yeah. So this is going to be one of our answers. This is what we're looking for. We can find the rest of them. We can find our y over x for all of the ones in our first quadrant, just to be sure. So we have square root 2 over 2 over square root 2 over 2, which this would be 1. Our y over x here would be square root 3 over 2 over 1/2. When we keep change flip, that would be just square root 3. So our answer is going to be pi over 6, but that's just one of our answers. Pi over 4 doesn't match, and pi over 3 doesn't match, so it's not those. So we want to check the other quadrants, but if it's pi over 6, it's going to be the ones with the same denominator. Here we're looking for positive and negative 1 over square root 3. So it's actually going to be all of the ones with 6 in our denominator. But we can do the math just to be sure. Let's do the same thing for 5 pi over 6. If I did the math here, it would be 1/2 over negative square root 3 over 2. Keep change flip. This would be 1 over negative square root 3, so that works. So 5 pi over 6 is going to be one of our answers. Let's check 7 pi over 6 too. So y over x would be negative 1/2 over negative square root 3 over 2. Keep change flip. This turns into positive 1 over square root 3, so that works too. 7 pi over 6. We said it's going to be the one with the same denominator, so we got to check 11 pi over 6 too. So negative 1/2 over square root 3 over 2. Keep change flip. So this would be negative 1 over square root 3. So this one works too. So here we have 4 answers. We're going to say x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Because we were looking for the positive and negative for 1 over square root 3 for y over x to be, we have 4 answers. So example 4 kind of gives us an idea of what to do with the first step in the directions. So it says to factor. When we factor, what does this have to be equal to? If I was going to factor, what do we want it to be equal to? 0. So let's make it equal to 0. I'm going to subtract 2 cotangent x to the other side. So we have cotangent of x times cosine squared x minus 2 cotangent x equals 0. How would I factor here? How would I factor? We want to take out the GCF, so I'm going to take out the cotangent x. We're left with cosine squared x minus 2 equals 0. Now, just like when we're solving by factoring, we're going to set each piece equal to 0. So I can make this equal 0 and this equal 0. So I'm going to have 2 equations here. Cotangent x equals 0. And cosine squared x minus 2 equals 0. Let's solve one at a time. Cotangent of x equals 0 is already solved for us. We already isolated the trig function. Cotangent is what over what? X over y. So we want to see where on our unit circle is x over y 0. So we know it's not going to be one of the ones in our first quadrant because we just did the math with y over x for all of those. We got 1 over square root 3, 1 and square root 3. So none of those will give us 0, but it's going to be one of our axes. So we want to see where x over y is 0. Let's do the math here. X over y would be 0 over 1. Is this 0? At pi over 2? Yep, so that works. Let's check pi. Negative 1 over 0. What does negative 1 over 0 simplify to? Undefined. So is that 0? Nope, so it doesn't work there. Let's check 3 pi over 2. So x over y is 0 over negative 1, which would simplify to what? 0. So 3 pi over 2 works. And then let's just check 0 also, because that's one of our axes. X over y would be 1 over 0. What does this simplify to? Undefined, so it's not 0. So our two answers here for the first part is going to be pi over 2 and 3 pi over 2. Now we need to check the second part too, our second equation. How do I isolate my trig function in the second equation here? What should we do first? How do I get cosine all by itself? Add 2. So cosine squared equals 2. What should we do next? Square root both sides. So cosine equals what? Plus or minus square root 2. Perfect. Cosine tells us we look at what? The x value. We want to see where on our unit circle is our x value, positive or negative square root 2. So let's go to our unit circle. We're looking at our x values here. Do we have any x values that give us positive or negative square root 2? Any of our x values? No. So this one's actually not on the unit circle. So it doesn't give us an answer on the unit circle. It will give us a value, but we're not going to worry about it. It's just not on the unit circle. So we only have our two answers here from the first little equation. So example 5 also kind of gives us a hint of what we're going to do in the directions it says to factor. So it's already equal to 0 here. How can we factor this? What should we do? If this was like 2x squared minus x minus 1 equals 0, what would we do to factor? We multiply the first times the last. So same thing here, we're going to multiply the first times the last. 2 times negative 1 would be negative 2. What are two factors of negative 2 that add to negative 1? Negative 2 and positive 1. So we have sine minus 2 times sine of x plus 1. Now we have to remember, if we start by multiplying the first times the last, if you're not factoring by grouping, what do we have to do with the first? We got to divide by 2. So don't forget, if you do it this way, you multiply the first times the last. Don't forget to divide by that first. So when we simplify, we get sine of x minus 1. And then if it doesn't simplify, move it in front. So this would be 2 sine of x plus 1. What should we do next? We're going to set both of them equal to 0. So sine of x minus 1 equals 0. 2 sine of x plus 1 equals 0. What should we do with the first one? Add 1 to move it to the other side. So sine of x equals 1. We can go to our unit circle and solve from here. Sine tells us we look at what on the unit circle? Y. We want to see where on the unit circle is our y positive 1. So where on the unit circle is y positive 1? Pi over 2 anywhere else? Nope, that's it. That's the only one where our y is 1. So x equals pi over 2. Let's do the same thing with our second equation now. How would we isolate sine in the second equation? Subtract 1. So 2 sine of x equals negative 1. Then what? Divide by 2. So sine of x equals negative 1/2. Now we want to see where on our unit circle, we said sine is our y value. Where is our y negative 1/2? 7 pi over 6, our y is negative 1/2. Anywhere else? 11 pi over 6. Perfect. So in addition, we have two other answers, 7 pi over 6 and 11 pi over 6. So we've got 3 solutions here. Let's look at example 6. So here, one of our trig functions is squared, and the other one's not. So that gives us an idea that we're going to have to factor. However, we can't factor when our two trig functions are different. How can we make them be the same trig function? We're going to use our identities. So our identity that involves sine squared is sine squared plus cosine squared equals 1. So I want to find what just sine squared equals. So I can subtract cosine squared, move it to the other side. So sine squared equals 1 minus cosine squared. So I'm going to take this 1 minus cosine squared and replace the sine squared with it. Since sine squared equals 1 minus cosine squared, I can just get rid of the sine squared and replace it with 1 minus cosine squared. Now be careful because that sine squared had a coefficient, so I'm going to leave that 2 out front. So we have 2 times 1 minus cosine squared plus 3 cosine minus 3 equals 0. What should we do next? Distribute the 2. So 2 minus 2 cosine squared x plus 3 cosine x minus 3. We can combine our like terms. So 2 minus 3 would be negative 1. So negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. What could we do next? Now we definitely could jump right into factoring here, but I don't love factoring when our leading coefficient's negative. How could I make it positive? We can divide everything by negative 1. I'm just going to flip the sign of everything in my equation here. So we have 2 cosine squared x minus 3 cosine x plus 1 equals 0. Now you definitely could skip this step and just factor with the negative leading coefficient. You just have to be more careful with your signs if you do that throughout the problem. So I just divided everything by negative 1, flip the signs so we can factor with a positive leading coefficient. What would I need to do next to factor here? Multiply the first times the last, we get 2. What are two factors of 2 that add to negative 3? Negative 2, negative 1. So we have cosine minus 2 and cosine x minus 1. If we start by multiplying the first times the last, what do we have to remember to do? Don't forget to divide by that 2. So cosine x minus 1. And then if it doesn't simplify, you can move it in front. So this would be 2 cosine x minus 1. Yeah. If you start by multiplying the first times the last, you have to, after you find your factors, you have to end with dividing. Unless you break it apart and factor by grouping. So you could do it either way. This way I think is a little bit easier. It's kind of more of a shortcut. You just can't forget to divide by that 2 if you start by multiplying. So we're going to set both of these equal to 0. Cosine x minus 1 equals 0. 2 cosine x minus 1 equals 0. So cosine x equals 1. We'll start by solving the first one here. Cosine tells us we look at what on the unit circle? The x. So where on our unit circle is our x value 1? Where on the unit circle is our x value 1? 0. Awesome. So our first answer is going to be 0. That's it for 1. Let's do the second one now. Let's solve for cosine. So we're going to add 1 to move it to the other side. Divide by 2. So cosine x equals 1/2. Same thing. Cosine tells us we look at the x value on our unit circle. Where is our x value? Positive 1/2. Pi over 3. Anywhere else? Pi over 3, perfect. So we have x equals 0, x equals pi over 3, and x equals 5 pi over 3. So those are our 3 answers.